This is the second video of session 7.6 Improper integrals. In this video, we will talk about the second type of improper integrals. That is, when the integrand becomes infinite. Let's start with an example. We look at this example. Evaluate the integral of 1 over square root x as from 0 to 1. Now we look at the integrand. The integrand is 1 over square root x. We sketch its graph. Suppose this is the graph of the function y is 1 over square root x. And x is equal to 1 is here. When x is 1, y is also 1. So you see that the integrand blows up at x is 0. This is the problem. So the idea is to consider the integral from a to 1 over square root x dx, where a is small and positive. Then see what happens as a goes to 0 from right. From the picture, we see that this integral should be the area of this shaded region. Now we evaluate this integral, the integral of 1 over square root x from a to 1. This is equal to the integral a to 1 x to negative 1 half dx. So the integrand of the antiderivative of this function is 2x 1 half. X from a to 1. So it's 2 square root 1 minus 2 square root a. So it's 2 minus 2 square root a. So this goes to 2 as a goes to 0 from right. We see the integral of 1 over square root x as from 0 to 1 dx convergence. And in this sense, we see that the integral of 1 over square root x as from 0 to 1 dx is equal to 2. Now let's introduce the definition. We suppose fx is defined on the interval from a to b, and that fx goes to infinity or fx goes to negative infinity as x goes to a from the right. So if the limit of the integral fx from c to b dx, c goes to a from right, exists, and is finite. We see the integral of f(x), x from a to b, dx converges. In this case, we define the integral of f(x), x from a to b, dx is equal to the limit the integral of f(x), x from c to b, c goes to a from right, dx. Otherwise, we say the integral of f(x), x from a to b, dx diverges. Definitions are similar. If instead f(x) is defined on a to b and f(x) goes to infinity, or f(x) goes to negative infinity as x goes to b from the left. So now let's look at another example. Determine for which values of p does the integral of 1 over s to p, s from 0 to 1 dx converges or diverges. Now let's look at this example. Again, we first consider p is not 1, and then consider the case p is 1. So when p is not 1, so we first consider the integral of 1 over s to p as from c to 1 dx. We know this is equal to the integral of s to negative p as from c to 1 dx. So this is negative p plus 1 s to negative p plus 1 x from c to 1. So this is when x is 1, so it's 1 over negative p plus 1 minus c negative p plus 1 over negative p plus 1. So if p less than 1, 1 minus p is positive, and this integral is 1 over 1 minus p minus c 1 minus p divided by 1 minus p. So this will goes to this is constant 1 over 1 minus p minus. So as c goes to 0 from the right, so this one will goes to 0 as c goes to 0 from the right, since 1 minus p is positive. So this goes to 1 over 1 minus p minus 0 is 1 over 1 minus p as c goes to 0 from right. In this case, the integral of 1 over s to p dx converges. and the integral of 1 over s to p as from 0 to 1 dx is 1 over 1 minus p. If p is greater than 1, 1 minus p less than 0, and the integral of 1 over s to p as from c to 1 dx, this is 1 over 1 minus p minus c 1 minus p over 1 minus p. So this 1 minus p less than 0, so this one will goes to infinity as c goes to 0 from right. So this is equal 1 over 1 minus p plus c 1 minus p over p minus 1. So this goes to infinity as c goes to 0 from the right. So the integral diverges. Finally, when p is equal to 1, the integral of 1 over x dx is equal to ln the absolute value x, then x from c to 1. So this is ln 1 minus ln c is negative ln c. This goes to infinity as c goes to 0 from right. This positive infinity. So we have the integral of 1 over x as from 0 to 1 diverges. So now we summarize what we get. The integral of 1 over s to p as from 0 to 1 dx converges if p less than 1 and has value 1 over 1 minus p, diverges if p greater than or equal to 1. So this is also an important example.